The chain rule. The chain rule is used when one function contains another function. So what ends up happening is you take the derivative, either using the power rule or the product rule or the quotient rule, and together with taking another derivative. So as mentioned, the chain rule is combined with the power rule. What ends up happening is you take the derivative of the function times the derivative of what's inside. In example 1, we want to take the derivative of y, which equals the square root of 3x squared plus x. Changing the radical to a fraction exponent, you're now going to do the power rule times the derivative of what's inside the bracket. So if I start with the power rule, 1/2 comes in front. I minus 1 from the exponent, so my exponent becomes -1/2. And I take the derivative of what was inside the bracket. 3x squared plus x is inside the bracket. So if I take the derivative of what's inside, that becomes 6x plus 1. So what happened here is I applied the power rule times the derivative of what was inside the bracket. And that's typically what we call the chain rule. Now I need to continue to simplify the expression. So since I have a negative exponent of -1/2, I bring that downstairs into the denominator. The 1/2 that was out front goes downstairs in the denominator. And I change the exponent of 1/2 back to a radical. In example 2, y equals x squared minus 3x plus 5, all to the exponent 4. So I'm going to do the power rule, bring the 4 out front, subtract 1 from the exponent, so I get an exponent of 3, and then I take the derivative of what was inside the bracket. So x squared minus 3x plus 5, the derivative for that is 2x minus 3. So what I've done in this question is I've taken the power rule times the derivative of what was inside the bracket. That's known as the chain rule. In example 3, you can see that I have two expressions for f of x. I have x squared plus 1 all squared times 4 minus 3x all cubed. So in this question, I'm actually going to do the product rule times the derivative of what's inside. So if I start off with the product rule, I leave my first expression of x squared plus 1 times the derivative of g, which is -3, leave my f function, then I apply the power rule, 3 bracket 4x minus 3x squared times the derivative of what's inside. So that gives me the -3 that you see there in red, plus the derivative of the x squared plus 1 all squared. So I apply the power rule, so the 2 comes in front, times x squared plus 1 times the derivative of what's inside that set of bracket, which is 2x, and the 4 minus 3x tags along at the end, all cubed. So what I've done here is the power rule and the product rule and the derivative of what's inside. Simplifying these, 3 times -3 is -9. And then what's inside the brackets follows. 2 times 2x gives me 4x in front, and what's inside the brackets just follows behind. You do not need to simplify it any further. So in this question, you can see that the chain rule was used with the product rule. So using two variables. Sometimes the chain rule can be used when there's two variables. So in the question, you'll have an expression that has two variables and one will equal something else. You can see here in this example that u equals 3x squared plus x, y equals the square root of u, and I'm being asked to calculate the derivative of y. So dy over dx is another way of writing differentiate y. So take the derivative of y. Well, y to the square root u is actually y equals u to the 1/2. So if I take the derivative of this, the power comes in front, so the 1/2 comes in front, u to the -1/2, and then I take the derivative of what's inside. Well, what was inside was u. What does u represent? From the question, u represents 3x squared plus x. So if I take the derivative of u, it's 6x plus 1. Simplifying this, the u to the -1/2 comes downstairs in the denominator to a square root. The 1/2, the 2 goes in the denominator. And what does u represent? U represents 3x squared plus x. So by substitution, I replace out the u. So what happened in this question was the power rule times the derivative of what's inside for u. In this next example, you can see that I have two variables again. Y equals 3u to the 4th plus 2u, and u has a value as well for an expression of x squared minus 2 square root x. Well, if I change that square root x, it becomes x to the 1/2. And notice that in the end, I'm going to substitute into the expression that x equals 1. So if I'm going to take the derivative of y, because dy over dx means take the derivative of y. So the exponent 4 times 3 is 12 u cubed plus 2 times the derivative of the variable. So what was my variable? My variable was u, and u is x squared minus 2x to the 1/2. So I need to take the derivative of u, which is 2x minus 1, because 2 times 1/2 is 1, x to the -1/2. So I've taken the derivative of y times the derivative of what's inside, and then I simplify it. I moved x to the -1/2 into the denominator. Now I still have two variables in this question. I have u and I have x. But according to the question, I said x equals 1. So if I sub in x equals 1 into what u equaled, I'll get a value for u. So if x equals 1, sub it into x squared minus 2 root x. The value for u equals -1. So now I have a value x equals 1 and u equals -1. Subbing both of these into the expression because I'm going to get a numerical value in the end. 12 times -1 cubed plus 2. 2 times 1 minus 1 over root 1. And the square root of 1 is 1. So simplifying, my answer is -10. The last example, I'm going to use the chain rule as well. So I'm asked to take the derivative of this. The derivative of this requires me to use the chain rule as with the quotient rule. So since I have the exponent 3, I take the power, so the 3 comes out front, minus 1 from my power, so I get 2. 3 times, in brackets, a plus 3 over a minus 5 squared. And then I need to take the derivative of what's inside. The derivative of what's inside requires me to use the quotient rule. The quotient rule yields a minus 5 times the derivative of the numerator, which is 1, minus, leave the numerator, take the derivative of the denominator, which is 1, and I square the denominator, a minus 5 all squared. The rest of my work I'm just going to simplify. Simplify what's in the square brackets. So a minus 5 minus a minus 3, because I need to distribute in the negative. The a's cancel to give me -8 in the numerator. Apply the exponent of 2 to the top and the bottom of a plus 3 and a minus 5. And then combine in the denominator a minus 5 all to the power of 4. 3 times -8 in the numerator gives me -24. So you can see that my final answer is -24 bracket a plus 3 squared all over a minus 5 to the power of 4. Using the chain rule, the product rule times the derivative of what's inside, and I had to use my quotient rule. So the chain rule basically represents a combination of derivative rules.